Bolton, are you going to verbalize problems or do you need to send me a picture? Bolton, can you hear me? Bolton, can you hear me? I can hear noise, I just can't hear your voice. Usually with geometry, it's fairly difficult to verbalize problems because most of the problems are based on drawings or graphs or figures.
Okay. Going to be sending,
Okay.
from what I know, two pictures.
All right. In the future, it's best to send those in advance just so we don't waste so much time. In other words, it's already 4:07. By the time I get those pictures, it'll probably be 8 or 9 minutes into the session. If you can send those right before 4 o'clock, then we can go to work on them immediately.
Did not seem to steady my hands.
What kind of phone do you have?
I have an LG Escape.
Does it have the feature where if you hold down the button, it will take 5 pictures quickly in a row and counterbalance any unsteadiness that you have? Mine can't.
Yeah, I do have that.
My phone
I do have that. Thank you.
Yeah, although to be honest with you, it's never helped that much. It's not that much better just holding your hand steady. I don't know. I've never been that impressed.
It's certainly gonna help me.
Good. Yeah, because there has to be a certain minimum resolution before I can bring it up and read it. So it's usually dependent on 2 things only, and that is the steadiness of your hand and the amount of light. And if you don't have good light, then just use the flash. But the best way is if you have good natural light.
Okay,
and send it to davidcowan1949@gmail.com.
Okay, sorry about this.
All
right. Yeah, I'm gonna try and send it in advance.
Yeah, no, that's the best way to do it. If with an hour session, we'll probably have enough time to cover the material. But I get that a lot with my half-hour session people, is that they waste the first 10 minutes sending me the material. They should send it in advance, and then we get a full 30 minutes in.
Okay.
Tell me when it was sent. Your phone says it was sent. And part of the secret to sending me emails is not to attach too many pictures to the same email. If you put like 5 pictures in one email, it really slows it down and it takes 2 or 3 minutes, sometimes longer, for me to get it. There I go.
I sent 2 pictures because that's all I need.
That's fine. I got it. Oh, this isn't bad. All right. Hold on a second. Let me download. Which one do you want to look at first? The one on the left or the right?
The bottom one.
Can't tell what that is. Look at my screen. There's one on the left, the one on the
right. The one on the right.
And where do you want to start? Well, these look interesting. Bolton, where would you like to start?
Okay. On question 1.
Okay.
We have to do 1 through 21.
Okay. So, what would the next figure look like in figure 1?
Okay.
The first figure is lower left. The next figure is lower.
And next
figure is upper right. The next figure is upper left. Next figure should probably be what?
Lower right.
I was going to say that, and then it occurred to me that I think maybe lower left. In other words, I think it might just be a repeating pattern of 4. Let me think about this for a minute.
Then again, it could be anything. It could be anything.
Yeah, I think you're right. I'm not sure there's only one correct answer. Lower left, lower right, upper right, upper left. Well, the next one has to be lower. I'm quite sure of that.
Yep.
And
I'm going to do lower right.
See, we're going
lower
right, left. I'd say lower left. And now notice that's a repeating pattern. And why is it repeating? Well, I got 2 L's to start with. And then I got 2 U's. And then I got 2 L's again. And then I got 2 U's. And after each L, it alternates. So this would be my best guess, but I can see where you can make an argument for the other. And let's take a look at number 2. These can be kind of fun. This is the kind of problems you're going to
one should be
on an IQ test. Have you ever taken an IQ test?
No.
But I get pattern recognition is a huge part of them, or a test for Mensa would be a lot of this kind of stuff. As opposed, this isn't that common in geometry. You're not going to get a question like this probably on the SAT test. But let's look at number 2. What would the next pattern be? Let's see.
Okay, I'm drawing it right now. It's pretty easy.
Okay, I see it also. This one looks pretty easy. So all you do is add 2 blue diamonds, and then you add 2 more white triangles, and then you add 2 more blue triangles, and keep going with that pattern. I can't quite see the right side of it, but all right. More importantly, from a math perspective, is numbers 3 and 4. These are much more common. These are sequences. I don't know if you've had much in the way of sequences yet. Probably not. You don't usually get that until you get to Algebra 2. But what do you notice about question 3? What's the next number?
Plus the pattern, well, it says first for the pattern. The pattern is plus 5.
Correct. Every number is plus 5 greater than the previous one.
Yeah.
Okay. So what's the next number?
14.
Okay. How about number 4?
I think the pattern is negative 1.5. Negative 1/2.
Times instead. This is very important. there's a difference between number 3 and number 4. Number 3 is an arithmetic sequence, or arithmetic series, excuse me, and there's two kinds. There's arithmetic and there's geometric. And number 4 is geometric. In other words, every term is a multiple of the previous term. And that multiple, you're correct, is minus 1/2. If you multiply every term by minus 1/2, you get the next term. And that is a geometric sequence.
So the next term would be 6.25.
Yes, positive, 6.25, exactly.
Okay. Write the if-then form, the inverse, and the contrapositive.
All right.
So this is just tedious.
This is
I'm getting out my definition to refresh.
Okay, I guess the only thing that really matters here is if you know what the converse, the inverse, and the contrapositive mean. Let's talk about, let's just do at least one of them. Let's do number 5. All right angles are congruent. What is the converse of that?
Okay. If angles, the converse wouldn't exactly work though.
Well, that doesn't matter. No, they're not saying that each of these is always true. They're not. Contrapositives aren't necessarily true, but
all congruent angles are right angles.
I think that's the inverse. If you want,
it'd be changing the hypothesis and conclusion.
I think the converse means not. In other words, no right angles.
No, that's the inverse. The inverse is negating it.
All right. I'll go with you. If you're looking at your book and you're sure that...
I'm looking at my definition.
Okay, good. Because I don't have my book open, and I don't tend to remember these words because these names never come up again, to be honest with you. The contrapositive does. The contrapositive says what for number 5? That's the most important one, really.
Okay.
If an angle is not congruent, if two angles are not congruent, then they are not right angles.
Right angles.
Is that a true statement?
Yes.
Yeah, and contrapositives are always true. One that I like to use is the following. These are all in the form if P then Q, okay? And if P then Q, let me write it over here. This is the most important part of this logic. If P then Q very seldom means if Q then P. If Q then P usually is not correct. And the example I use is if you live in Colorado, in quotes, that's the P, you live in Colorado, comma, then the Q is...
You live in the United States.
Yeah, you live...
Then you live in the United States.
United States. Now, if we took...
If you live in...
the reverse of that, it's clearly not true. If you live in the United States, you don't necessarily live in Colorado.
It could be true.
Right, but it isn't necessarily true. That's what you want with these, is they have to always be true for them to be true. However, the contrapositive is true. What's the contrapositive to that statement?
If you do not live in Colorado, if you do not live in the U.S., then you do not live in Colorado.
And that is true. Always.
Yes.
And I've never seen an if P then Q statement whose contrapositive was not true. So the contrapositive is always true. The converse is sometimes true. The inverse is sometimes true. But usually the logic mistake that most people make is they assume that if P then Q always means if Q then P also. And we can see that it does not.
Mm.
All right, let's see. Let's look at number, where do you want to go next? We can go.
I'll do the big word. Let's just go to 9.
All right. If you decide to go to a football game, then you will miss band practice. Tonight you're going to the football game. Using the law of detachment, what statement can you make?
Well, you're not going to make it to band practice.
You're going to miss band practice, right? 100% of the time. According to the first sentence, if you go to the football game, then you will miss band practice. And they're saying you decided to go to the football game, therefore you will miss band practice. I didn't know it was called...
Well, no way would I choose going.
I'm not sure why it's called the law
of
detachment, but it's pretty clear-cut, I think, what the answer is there. Let's look at 10. Do you have answers on these, incidentally, in the back of the book?
What?
Do you have answers on any of these in the back of the book?
I don't exactly want to check them because I don't want to have to find them.
Well, okay. Occasionally it's worth, I wouldn't mind seeing the answer for number 1 because I'm not 100% sure whether it was yours or mine. But that's okay. And also because I'm not positive what the law of detachment is, I gotta believe that it means that you're gonna miss the band practice. What else could it mean? Okay, so
yeah.
Number 10. If Margot goes to college... I'm sorry, what?
I already read this. I'm going to guess that the answer is if Margot goes to college, then she will need to buy a lab manual.
Okay. Hold on. If she goes to college, then she will major in chemistry. And if Margot majors in chemistry, then she will need to buy a lab manual. Using the law of syllogism, what statement can you make? Yeah.
That if Margot goes to college.
You got it. You got it. Unless she's like me. No, I still had to buy a chemistry manual. When I got to college, my first major was chemistry, but I very quickly shifted to physics. Just because I found out I didn't like chemistry nearly as much as I thought I would. But then I shifted from physics to math, and I ended up in pure math. I found it more to my liking than either chemistry or physics. But, all right.
I'm probably going to do math.
Oh, you think? You like? Yeah, you're pretty good.
Yeah, I'm going to
definitely should do one of the STEM subjects. You know,
I'm going to minor in English.
You know what I mean by STEM, right?
Yeah, science, technology, engineering, and math.
Yeah. No, if a person has the talent, I always recommend that, just because you want to apply your talent where it's best suited. And if you have skills in math, which you do, you should go into one of those areas. And I think a person is happiest doing that also. In other words, if I had skills in math and I tried going into English or something, I might not be happy. But all right.
Well, I'm going to minor in English.
Well, that's okay. That's not a bad combination. Yeah, although it depends on where you go to school. It's like when at Mines, they only offer engineering degrees. They didn't have an English degree. So I was majoring in math and minoring in geophysics. But they only had like 9 choices, and all of them were engineering degrees. So, all right, let's look at number 11. Use the diagram to write examples of the stated postulate. A line contains at least 2 points. Well, what part of the diagram works for that?
Line NQ.
Okay.
Wait. Yeah.
Yep. No, that's fine. It doesn't have to be a line that goes to infinity. It's got 2 points on it. It's a line if it's got 2 points. Number 12, a plane contains at least 3 non-collinear points. What 3 points would that be?
It could be R, Q, and S if we're talking about plane Y.
Not R. No, not R. How about M, Q, X? Notice that RQX is not a plane. That's a crooked plane. What you have there in the diagram is 2 planes intersecting, right?
Mm-hmm.
There's various ways you could describe the vertical one. I could describe the...
Well, I said RQ and X.
You said RQX, right? Look where R is outside of that plane.
No, I said RQ and S, which is on plane Y, all 3 of those.
Oh, you said S. I got you.
Yeah.
I heard
X is an X. Yeah, X isn't a point, it's a plane.
No, you got it. Okay. If 2 planes intersect, then their intersection is a line.
Line QN.
Yeah. Okay. Solve equation 14. And write a reason for each step. Okay, hold on a second. Let me write it over here. Okay. What's the first step and what's the reason for it?
Okay, we have to subtract 31. So we can get...
What's that rule? There's an algebraic principle that you have to rely upon there. That's called the subtraction equality.
Property?
Yeah, the subtraction property of equalities.
I was blanking there because I thought it meant something else.
That's all right. I really don't like what they do here, to be honest with you. I far prefer telling everybody that the rule of algebra is you can do anything you want to the left side as long as you do it to the right side. It's not limited to subtraction or addition or multiplication or division. You can square it, you can take square roots of it. Once you get into calculus, you can take derivatives of it, you can take integrals of it, you can take logarithms of it. In other words, you truly can do anything you want to one side of an equation as long as you do it to the other. So separating them out, each of these properties is, to me, a little silly. But, okay, so that gives you 9, we'll play the game. So that gives you 9x equals minus 54. Now what?
Yeah. I already divided by 9 through the division property. He doesn't actually care if we do equality for those. He just cares if we use it for, like, transitive property.
Yeah, I know. Okay, cool. All right.
And I got x equals...
Let's just go on to 15. Yeah. Yeah, that's all.
Yeah.
X equal minus 6. Okay, so 15.
I already know the first step, distributive property.
Okay, what's the next line?
That would be -7, no, sorry, 7x minus 14 equals 40. I need a better eraser.
Equals 42 by the distributive property.
Yeah.
Okay, next line.
You add 14 to both sides.
7x equals 56 by the additive property. And finally, x equal 8 by the division property.
Okay.
All right, I don't think we need to do 16. let's go on and look at 17 through 19. Are you cool with skipping 16?
No, I want to do 16.
Okay. I'm not sure I see the entire problem. Read it to me. It's 26 plus 2 times 3x plus 11. It looks like something else. Must
equals 1 equals negative 18x. So,
negative
26
okay.
plus.
What's the first step you're going to do?
I'm going to use the distributive property.
Okay. Read it up.
Okay, 26 plus 6x. 26 plus 6x plus 22 equals negative 18x.
Okay.
Let me write.
Now what?
This is a lot of writing. Then we have to combine like terms and get 48 plus 6x equals negative 18x.
Okay.
And then, yeah, combine like terms.
Okay. So what's the next line?
Just give me a minute. Next, we have to subtract 6x.
Yeah, if you could make both coefficients positive, then I would try to do so. But whether I take the 6x to the right or I bring the 18x to the left, I'm going to end up with a negative coefficient regardless.
Yeah.
So might as well just do the straightforward thing, which is that. And now what?
And I get negative 24x equals 48. Divide by negative 24.
You get x equal what?
X equals negative 2, right?
Yeah. Now, is there any step there where you have a question as to what is the reason for each one?
Nope.
All right.
Nope.
All right. Let's go to 17. So 17, 18, and 19 call for either A, B, or C, the reflexive, the symmetric, and the transitive. So 17, if...
This is, 17 is B.
Yeah, it's basically saying if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1.
18 is reflexive property.
Correct.
And that must mean 19 is transitive.
Correct.
Because they wouldn't leave that out.
Right. No.
This is
19. If FG is equal to JK and JK is equal to LM, then FG is equal to LM. Yeah, that's transitive. Okay.
Okay, so for this, all we need to do...
It's an easy mistake to make on 19. It'd be really easy to say on 19 that that was by substitution.
Ooh.
Because if JK is congruent to LM, then I'll just substitute LM for JK and I get FG is congruent to LM. So I agree that it's the transitive property, but if you were looking at that on a test and it wasn't multiple choice, I think I've made the mistake of calling that the substitution property. I'm not sure that it is, but I'm not sure that it isn't either.
Forgive me, I'm going to cheat and use a calculator here because I don't want to do this all.
Talking about for number 20?
Yeah, I got the value of y, which is 18.
So your equation is what I'm more interested in. So your equation says...
I got 7y. I'm using vertical angles congruence here. 7y equals 5y plus 36. Subtracted 5y, y got 2y equals 36. Divided by 2, got y equals 18.
Cool. And the second equation for x?
I guess I'll do that now. 3x minus 21 equals 2x plus 4.
Yeah.
Add 21.
Yeah. And that one, the second one, it's very, very clear that your x's should go on the left and your numbers should go on the right.
Yeah.
Because it leaves both coefficients positive. If you were to reverse them and take your x's to the right and your numbers to the left, you'd get the same answer, but you'd be dealing with two negative signs unnecessarily. All right. Number 21 as a proof.
No, I'm not done with that yet.
Okay. Now, am I looking at everything that there is to look at here?
Yeah.
Okay, there's no steps or anything. So they make you do it in honors geometry. They make you do it the hard way. Okay? The easy way on two-column proofs is when they give you a column of statements and they give you a column of proofs, and every row has at least one or the other. That, to me, is the best way to learn two-column proofs. As opposed to this question where you have to figure out everything on your own. But we can still do it, okay? So we have statements and we have reasons.
Okay.
First statement is, what's that?
This was optional homework, and I still have another page to go, so this better be extra credit.
Okay, we have a little less than a half an hour. Would you rather go to your second page and come back to this?
No.
Okay, let's do this one then. What's always the first statement?
Given.
All right. So we got
1.
AX is equivalent to DX, and you put both givens together. No reason to
yeah.
2 rows on them. That's given. All right. So, and what I generally like to do on these is down at the bottom, I don't know if it's going to be statement 5 or statement 6 or statement 4. We'll just call it 5 for the moment. 5 is going to be what we're trying to prove, right? This isn't a bad way to do it. Okay, and I don't know what the reason's going to be yet, but let's go through some of these. Let's see how we can prove this. AX is congruent to DX. That makes that an isosceles triangle. And XB is congruent to XC, makes that an isosceles triangle. That angle is congruent to that.
So this right now means that, oh, never mind.
Well, I think they're leaving out some information here. First of all, they don't tell us that that's a rectangle, right?
Nope.
And that's pretty critical, I think, in this proof. That we know that that's a rectangle.
Right now. I don't know what to do.
What's that?
I'm confused right now. I don't know what to do next.
Well, let's think about this for a moment. If I were to draw a picture, I'll try to draw one right in here like this. Let's draw a picture of this thing. And the only thing they've told us is that that's congruent to that, and that that line is congruent to that, correct? That's all the information they've given us. You with me? That actually tells us quite a bit. We know congruent triangles. We do know, we can figure out that that angle is congruent to that angle. So now by side, angle, side, we know that triangle 1 is congruent to triangle 2.
Yep.
This is a good way to do two-column proofs is to kind of work your way through the logic and then figure out how to put it in a two-column proof. But our logic says that triangle 1 is congruent to triangle 2, correct?
Uh-huh.
And we're trying to prove that AC is congruent to BD. Well, if those two triangles are congruent...
Wait, no, what is the reason for 2?
Vertical angles. Well, let's talk about, for 2, you mean triangle 2?
Yeah, no, for,
In other words, these two angles here are congruent because they're vertical.
Yeah.
And the two sides of that triangle are congruent. Ah, I see what you're saying. That doesn't make the two triangles congruent. My apologies. You do have to assume that that is a rectangle, I think. If you don't assume that that's a rectangle, and yet they haven't given it, they haven't told us it's a rectangle, because all we know is that triangle 1 is isosceles and triangle 2 is isosceles. And these two angles are equal. But we don't know that AX is equal to BX or XC. So all they've told us is that AX is equal to DX. So I think this problem is flawed. I think that if this is not a rectangle, you actually cannot prove that AC is equal to BD.
Well, then let's assume it's a rectangle.
All right. If we assume it's a rectangle, well, now there's theorems that say the diagonals of a rectangle bisect one another, which means that this length here is equal to this length there.
Mm-hmm.
And now we do have congruency, but, and because the two triangles are congruent, well, then this length here and is equal to this length here, and dx plus xb is that length plus that length, and it's equal to that length, which is the same as that length. So that's the logic you would go through to prove that AC equals BD. And I can erase that picture if you like and write out every step.
No, it's fine.
You want to go to the next page instead?
Yeah.
All right.
208 on my book.
All right, where do you want to start here? I can tell you used a flash. That's the only drawback of a flash. You see where it has these bright spots?
Oh, I can just tell you that.
Well, that's fine. I'm just telling you, when you use the flash, that's the only downfall of it. I periodically run into the same thing. Whereas if you have an area in your room that's got sunlight and you can put the page in the sunlight, you don't get those kind of spots in it. All right. So where do we want to start here?
1. We're going 1 through 24.
Well, the way you took the picture, I cannot see that drawing. You see my problem?
Yeah, no, it's fine. I'll just say it. I'll tell it to you.
Okay.
So, classify the pairs of angles as corresponding alternate interior, alternate exterior, or corresponding or consecutive interior.
Is that what the figure looks like?
Yeah.
And
But the lines aren't parallel.
Where's 2?
There's a transversal going through 2 non-parallel lines.
2 non-parallel? Oh, these lines are not parallel.
No.
Okay, all right. And this is 2, and this is 3, and that's 4.
Yeah, we just need to classify, though. So they're not congruent, but they're still classified as
1 and 8.
alternate exterior.
Okay, what are 2 and 6?
I'm
Corresponding. That's what 2 and 6 are, is corresponding. In other words, corresponding means that they occupy the same side. They're on the same side of the transversal.
I know what corresponding are.
All right, cool. How about 3 and 5?
Consecutive interior.
4 and 5.
Those are alternate interior.
Right. It's interior because it's inside the parallel lines, and it's alternate because it's on alternate sides of the transversal. 3 and 7.
Give me a minute. Give me a minute to write this down.
Okay.
Um, 3 and 7. Those are corresponding.
Correct. And 3 and 6.
Those are alternate interior.
Okay, cool. All right, so for number 7, I can see that. Let me look at it for a second. What is x?
X is 140.
Okay, and number 8, give me an equation that allows me to solve for x.
Okay, so 50 equals 18 x minus 22.
All right. I don't think we
add 22.
need to test your equation solving skills. They're pretty good.
I need to do the equation.
All right. Oh, I see. Okay, for your homework.
Yeah.
All right, go ahead and do it.
I may do this on a calculator because I don't feel like doing the arithmetic. Because I'm kind of in a rush.
That's fine. I always think it's okay to use a calculator when you're dealing with 2 digits. If you're doing single digit stuff, totally different story. I think you should always try to do those.
X equals 4.
All right. And number 9, again, I can't see, but give me the equation that you're going to come up with.
Okay. 107 equals 4x plus 11.
All right. They're both alternate exterior. 4x plus 11?
Yeah.
All right. Solve that.
Okay. 96 divided by 4. X equals 24.
No. What am I doing wrong here? Oh, yes. Excuse me. 4 goes into there too. Yeah. Had a brain fart for a moment. Okay. Where are we at?
Find the value of x that makes m parallel to n. So that would have to be 43 degrees.
Correct. In other words, the sum of the obtuse and the acute always are supplementary. Whenever you have parallel lines and a transversal, that's the most important thing to remember. You end up with, I don't really, I know they teach this alternate interior and alternate exterior, but the thing you want to remember 5 years from now is that you create 2 angles, an acute angle, an obtuse angle, and they are supplementary to one another, and that's it. So on number 11, what's the equation?
128 minus x equals x.
Okay, because they're both the acute angle. And incidentally, the corollary of this theorem is not that if you have 2 parallel lines, these 2 angles are equal. The reverse of that is true. In other words, the inverse is true. The corollary is the inverse. If these 2 angles are supplementary, then these 2 lines are necessarily parallel. It works both ways. It's an if and only if theorem. That's what they call that. So how do you solve this?
So you add x to both sides and get 2x equals 128. Divide both sides by 2, and you get x equals 64.
All right. The equation on number 12.
Okay. X plus 17 plus, okay, so 73 plus x plus 17 equals 180 because they're supplementary.
Right, because we have one as an obtuse, the other is acute, so they're supplemental.
Yeah. So you combine like terms, and you should get 90 plus x equals 180, and subtract 90 from both sides, and x equals 90 degrees.
All right. Now number 13. Back to algebra.
Find the slope of the line that passes through the point. Do I have to explain this? Because
just give me an answer. As long as you can do it, that's the only thing that matters.
This is undefined.
Yeah, very good. In other words, regardless of what the change in y is, which in this case it's 5.
It goes straight up. It goes straight up.
Right. So it's not really undefined, is it? It's vertical. Now,
yeah.
Well, I guess you could say it's undefined. There's only one line that's undefined, and that's a vertical. That has an undefined slope, and that's a vertical line. Okay. And the next one.
Okay. And you get 10 over 3.
Okay. So that's the slope. Yeah. 10/3.
It's negative 10 divided by negative 3, which brings
you can actually do those in either way. In other words, you don't always have to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is a perfect example where it really makes more sense to do it this way because you deal with all positive numbers. The only thing is always make sure you go the same way in the numerator and the denominator. As long as you do this, either of these is correct. It turns out if you use this one, you immediately get 10 over 3 and you don't have to deal with negative numbers. And that's a better answer than 3 1/3. Improper fractions are better, especially when you're dealing with things like slope.
So on 15, I get negative 7 over 6.
Okay, so negative 7/6 is the slope.
Yes.
Now, number 16, a little more complicated. They give you the slope and they give you a point.
Yeah.
Now, are you familiar with point-slope format?
Of course. Yes. And I know how to do this. You just plug in the numbers.
Yeah. Let's start. I love starting with the general format on all problems.
So, how I'm going to start out, y equals 3x plus b, because we have the slope already. Then I'm going to plug in 4 for y.
Hold on a second. Hold on a second.
Negative 6.
Point slope format is not slope-intercept format. That's point slope format.
Yeah, I know that.
Intercept format is y equals mx plus b. Well, it turns out that point slope format is a lot easier when you have a point and a slope. It's one step. Notice what the step is. Y minus the y1 point. They give us the slope times x minus the x1 point, which in this case is minus 2. We're doing 16, right? So that becomes a plus 2. There's your answer in one step. And that is a fine answer. You don't need to put it into slope-intercept format. The way you are going to do it works, but it's harder. In other words, you have to solve for b. And the way I could solve for b would be I would put the y coordinate in there. 4 equals the slope times the x coordinate. And then I could solve for b. So I get b equals 10. And so now my formula is y equal 3x plus 10. But notice that was 4 steps or 3 steps to get the answer. Whereas the advantage of point slope is it's 1 step. There's nothing else you need to do. Now, you could, how do I get 10 in one case and 9 in the next? What did I do wrong here? Let's see. What did I do wrong? In other words, if I distribute this out, I end up with y equals 3x minus 9. How did I get this? 4, the y coordinate is 4. The x coordinate is minus 2. Slope is 3. How is b not equal to 10? So that's the proper equation of that line, but it has to agree with the point slope equation, and it doesn't seem to. Oh, I see what I did. I used 3 up here instead of 4. I was reading number 19 when I should have been reading number 16. This is y minus 4. That's the answer right there in the rectangular box. In other words, you take y minus the y coordinate, which is 4.
Yeah.
Okay, and that does, if you do convert it to mx plus b format, you do get that. So, are you sure you've had point slope format? They don't always teach point slope format right off to you. They usually teach you slope intercept format and let you go with that for a while. But there actually is this other.
He did.
Okay, and there's this other thing called point slope. Point slope becomes more valuable as you get higher up in math. Like when you get to calculus, you want to know point slope. What's that?
It's 459.
Yeah, I know. I was going to end it right there. Okie dokes. Bolton, I will talk to you next week. Good luck on your...
Good. Yeah.
All right, bye-bye. I'll call Logan. Is Logan's phone working, or do I need to send you the meeting ID number?
No. He has a working phone. He got a new phone.
Okay, cool. Talk to you later.